Welcome to Real Physics. This is part of the series about variable speed of light, and today I'm talking about gravitational waves. Why variable speed of light at all? Because it was Einstein's very first idea when he developed general relativity back in 1907. This is in my history video, and you might also want to watch this playlist about various topics. Variable speed of light has a lot of explanatory power for cosmology. But you might ask if it's in agreement with the observation of gravitational waves, which took place in 2015. And well, before going into detail there, let's talk about the evidence for gravitational waves. And I agree here with Sabine Hossenfelder largely. She was one of the first people publicly challenging these claims. And she's very courageous and put this article out, have we really measured gravitational waves? She also said in a video, I think the gravitational wave community is doing a crappy job in explaining their business. That's also in part true, but let's say there are also very honest and diligent people working in the collaboration. For example, Jeff Kissel, the control engineer in Hanford, he took a lot of effort to answer all my questions in collecting old material, and he was really nice, even if we did not agree. But well, Sabine Hossenfelder has certainly some other experiences with the honesty and behavior of the people there. But let's look at the data. Let's look at the important things. There are some things that do not add up, and she says she does believe, or let's say she does not doubt the very existence of gravitational waves, but she cannot blame us if we do doubt. And I'm glad she does not blame me, because actually I still have doubts about the discovery. And you might look up this article in New Scientist in October 2018, and they are dealing with some, well, serious issues about the publication, about the central first picture of the publication in Physical Review, which was a little bit fudged and adapted by hand. This is not technical, it's not good science, but it may not justify to doubt the very existence. But if you look at the data, there are a couple of strange things. Well, first thing is incredibly heavy black holes are needed to explain these data, and if you compare these to earlier observations, it's just indicates that there might be something which is not okay. And then you have huge false alarm rates. There were lots of signals believed to be a gravitational wave first, and then nothing. I read an article in my Medium account. You might watch this. There are a lot of references, and most of the references go back also to the work of Andrew D. Jackson at the Niels Bohr Institute in Copenhagen. He's a fantastic scientist, very honest and old-style scientist. And I think the most important thing you need to understand is that LIGO's method of data analysis is fundamentally flawed. Why? Because they use templates. It means that they observe the data and they have their set of theoretically calculated templates, and they then compare, oh, this fits, this does not fit, that fits very well, but that's not the method you detect the very existence, okay? And Jackson compared this to identifying the number of on a car plate. I mean, if you know that this is a car plate, you can even extract from this very, very noisy signal the true signal. But if you don't know it's a car plate in the first place, you cannot extract any information from this. So this is the principal epistemological failure of the data analysis. Why are they doing this? Because they say, oh, it's justified because we already have established the existence. Now, if you look, what did establish the existence of gravitational waves? There were basically two events. The 1708-17 event, which was taken as independent evidence. Why this was a famous event? Because parallelly they had other discoveries, other signals in the Fermi telescope and so on. But the gravitational signal was very, very poor. So this gravitational signal of 170817 would never have been a valid detection of a gravitational wave for its own. Just the combination made it very interesting. Okay, and there are lots of strange details also regarding the discovery. I cannot mention in this video. And then, of course, the even more famous signal 150914. Okay, sorry, 150914. Yeah, this was before the official start of the measuring run without any security measures. And I think it's simply not okay if the entire discovery, if the entire belief on the existence rests on this. And still, I don't know the very last data, but until I gave up to deal with the matter 2 years ago, this was still the strongest signal. A couple of days discovered before the start, and then you have 5 years and detector upgrade and many more possibilities, and it's still the strongest signal. This is strange, and I think it becomes stranger every day. On the other hand, I mean, every day the sociological conviction becomes stronger that gravitational waves are established, because every day new PhD projects are started. So sociologically, I don't think we can revert this, but I still have very grave doubts about the very existence. And again, I don't go into the details here about the circumstances of this discovery. There is another article, 5 years of gravitational waves. And well, let's say I would have loved to dig deeper into the matter. I met also Jackson. He is a wonderful scientist, but I have lost a very important co-worker. So, I mean, at a certain point I have decided to let it be. However, from historical perspective, I think you're still not to blame if you have these doubts. Keep in mind there is a decade-lasting confirmation bias of gravitational waves. This interview with Harry Collins, he wrote a very good book about the history of gravitational wave detection. And you know, I mean, it's always much more interesting and much more fancy to have a discovery than a non-discovery and explain your signals in another way. So there were predictions and no confirmation, and then year by year they downgraded their predictions and predicted smaller and smaller signals. And of course you run into the increasing risk of declaring artifacts as a signal. That's, I think, the historical perspective one needs to take. And even the prediction of Einstein was not that clear cut. I mean, he said he predicted the gravitational waves, but then he was not sure. In other instances, he even retracted the prediction. So it's a dynamic that it's not fully convincing from a historical perspective. That being said, I mean, I do not blame you either if you believe in the existence of gravitational waves. To add Wittgenstein here, nothing is more difficult than not to deceive yourself. But as a matter of principle, you can imagine gravitational waves also in the variable speed of light context, because you have if you have regions of, say, lower c, this region could theoretically propagate and you would see a signal. However, it would not be the same signal. I guess it should be visible even in one arm. I don't know if these two-arm detectors are now blind for that kind of signal or not. I just cannot tell you. Would be a reasonable objection. Why don't we have stumbled across these variable speed of light versions if they existed? I don't know. There are people thinking about theorizing about variable speed of light, gravitational waves. If ever you could start from such a generalization of the wave equation I have mentioned in another video, the gravity video, and that would be a nonlinear extension of the concept, and you can think about waves. As I said, the conventional form of gravitational waves is hardly compatible with the variable speed of light idea, but I think there are still good reasons to doubt the very existence. From a natural philosophical point of view, I don't think it is satisfactory if we have these two kind of waves, because at the very end you want to unify gravitation and electromagnetism, and light is an electromagnetic wave. So if you think about a unification, why should there two kind of different waves? I guess that variable speed of light is rather something that potentially opens this way to unification, because you explain gravity with electromagnetic waves. So it's more desirable if you have just one type of waves. But this is of course my personal take. You might agree or not agree. Despite being widely accepted in the scientific community, there is still some reasonable doubt about the existence. The prediction is not unchallenged, and there is a decade-long confirmation bias. Gravitational waves are possible in variable speed of light. They would, however, show different characteristics. From the perspective of natural philosophy, as I said, gravitational waves are not satisfactory. If you want to go into more detail, you'll find my paper in Annalen der Physik, and there is another paper with my co-worker Jan Preuss about this version of variable speed of light, and there is a chapter about gravitational waves in my 21 edition of Bankrupting Physics, and of course there is my book Einstein's Lost Key that covers all the topics of variable speed of light, and there is a new edition in 2022. If you enjoyed the video, don't forget to like it, and if you're interested in fundamental physics, subscribe to this channel.